This video lecture addresses ecological restoration in regards to global climate change. There seem to be two main concerns regarding ecological restoration as it relates to changing climate. First, global climate change will complicate restoration projects because we cannot use past climate to predict future conditions. Second, ecological restoration offers a way of ameliorating some of the effects of climate change. We will address each of the major concerns in turn. First, global climate change will complicate restoration projects. There are myriad ways that a changing climate will make restoration work more difficult. For example, the range of species will likely shift. What does this mean for how we determine what is native to a restoration site? This image, which is figure SPM5 on page 44 from the Intergovernmental Panel on Climate Change IPCC 2014 report, addresses the possible need for assisted species migration, which could be employed as part of a restoration initiative to avoid extinctions and ecological disruptions brought on by climate change. The graphic presents an estimate of the maximum speed at which species can move, kilometers per decade, as a function of the type of organism, for example, from trees to rodents to freshwater mollusks. The IPCC suggests that, quote, many species will be unable to track suitable climates under mid and high range rates of climate change during the 21st century, medium confidence. Lower rates of change will pose fewer problems. Some species will adapt to new climates. Those that cannot adapt sufficiently fast will decrease in abundance or go extinct in part or all of their ranges. Management actions such as maintenance of genetic diversity, assisted species migration and dispersal, manipulation of disturbance regimes, for example fires, floods, and reduction of other stressors can reduce but not eliminate risks of impacts to terrestrial and freshwater ecosystems due to climate change, as well as an increase the inherent capacity of ecosystems and their species to adapt to a changing climate. High confidence. End quote. Changing weather patterns through changes in the total volume, magnitude of storms, intensity, or frequency of severe weather events may alter ecosystem functions, like the flooding regime in a wetland. Given that engineering hydrology is already difficult, how will these weather events alter the flow, seasonality, frequency of inundation, or other important factors? An example of the enormity of considering climatic shifts at the global scale is shown here in Figure 1 from the Frequently Asked Questions 3.2 section from Trenberth et al. 2007. Quote, the most important spatial pattern, top, of the monthly Palmer Drought Severity Index, PDSI, for 1900 to 2002. The PDSI is a prominent index of drought and measures the cumulative deficit relative to local mean conditions in surface land moisture by incorporating previous precipitation and estimates of moisture drawn into the atmosphere based on atmospheric temperatures into a hydrologic accounting system. The lower panel shows how the sign and strength of this pattern has changed since 1900. Red and orange areas are drier than average, and blue and green areas are wetter than average when the values are shown in the lower plot are positive. The smooth black curve shows decadal variation. The time series approximately corresponds to a trend, and this pattern and its variation account for 67% of the linear trend of PDSI from 1900 to 2002 over the global land area. It therefore features widespread increasing African drought, especially in the Sahel, for instance. Note also the wetter areas, especially in the eastern, North and South America and northern Eurasia. Adapted from Dye et al. End quote. Applying such global models to local restoration projects, along with their uncertainty, can pose an obstacle in planning, implementation, and project support. These are just a few of the complications that restoration projects may face in the coming years due to a changing global climate. In 2007, in a joint conference with the Ecological Society of America, ESA, Ecological Restoration in a Changing World, held in San Jose, California, the Society for Ecological Restoration International, SER, issued a position statement on global climate change, which was endorsed by the ESA Governing Board with some 4,500 people in attendance at the meeting. The SER Global Position Statement on Ecological Restoration, a Global Strategy for Mitigating Climate Change, states the following, quote, "The overwhelming scientific consensus is that global climate change is a real and immediate threat that requires action. Defined as an intentional activity that initiates or accelerates the recovery of an ecosystem with respect to its functions, integrity, and sustainability, ecological restoration is one of many tools that can help mitigate climate change. Humanity depends upon the services provided by ecosystems. These services include products such as food and timber, regulating services such as carbon sequestration, disease control and flood protection, and cultural benefits such as places to recreate. As an example of a regulating service, forests remove carbon dioxide from the atmosphere and sequester it in their biomass, thereby capturing a gas that contributes to global climate change. In order to continue to obtain ecosystem services, terrestrial and aquatic ecosystems need to be protected and, where possible, restored. SER strongly urges local, regional, and national governments, international development banks, and non-governmental organizations, as well as private institutions, to work to maintain ecosystems and to plan, finance, and coordinate ecological restoration projects and programs as part of a comprehensive global strategy for mitigating climate change and its effects. Developed nations should actively support restoration programs throughout the world by providing financial support, sharing technology, and committing expertise." End quote. Ecological restoration may hold promise for ameliorating the effects of global climate change, even with the inherent uncertainties in the future. The SER position statement highlights this potential. Possible strategies for ecological restoration include mitigating storm damage, creating habitat for migrating species, and creating carbon sinks, for example. Thinking about how restoration will be used in the future brings us back to the definition of restoration. Will we be talking about remediation or rehabilitation instead? Let me try that again. Will we be talking about remediation or rehabilitation instead of restoration? What is the future promise for true ecological restoration? The following references were consulted in developing this video lecture.